Hello, everyone. What I want to do is one final example, basically that I added to the end of the special loan situations part one PowerPoint. And this is it's a bit of a pain, but this is kind of illustrating where you need to be super careful, but just be a little careful using our retrospective and prospective simplified formulas when we have constant payments and constant interest rate, either for the first couple of years, periods rather, or the last couple of periods. That Okay, so we have a 30-year, $100,000 loan, constant yearly payments, 2% for the first 10 years, 2.5% for the next 10 years, and 3% for the last 10 years. So constant payments, but interest rate changes. We have 3 interest rate changes. Find the outstanding balance after 8 years, and the outstanding balance after 25 years. It's Okay, so let's get to it. So annoying thing is, of course, getting the constant payments. So let's do that. All right, so I'll just draw the time diagram as usual. Real quick here. We've done this before. All right, so call constant payments K. So 10% until t equals 10. So 10%, 2%, 2.5% here. And 3% for the last 10 years. All right, so yeah, at the very least, I guess what I could do, use different colors for the kind of different payments that we're doing. So first of all, the present value loan amount is 100,000, so that's the present value. So I'll just do the first 10 black here. So really nothing here. Present value of these 10 payments at 2%. KA 10.2. I'll do these here in red, I guess. So really want to add, this would be at 11. I guess that would be circled. Include that, not necessary, but we'll include that. All right, so as usual, the present value gives me the present value at the beginning of the first payment period. First payment period here is 10 to 11, so that this K occurs at the end of the first payment period. So we have to discount by 10 years. So it's KA 10.025, but we discount by 10 years from 10 to 0 at 2%, because 0 to 10 interest rate is 2%. So 1 over 1.02 to the 10. And same thing for the last one. 1 here, okay. Do blue here. So here the first payment period is 20 to 21. So present value gives me present value formula always gives me the present value at the beginning of the first payment period. Beginning of that first payment period for these last 10 payments is 20, because the first payment period is 20 to 21, with payments starting at the end of the first payment period, 1. So that 10 times fast. And yeah, so black. And then I'll do this in blue, same thing, K810.03, 1/1. Here we gotta be a little careful, because we discount it by 10 years to go to 10 at 2.5%. So this is what I have here is basically the present value at t equals 10, but to go to 0, we discount by another 10 years at 2%. So it's got to be a little super careful, but all right, so let's do this in a calculator. And one little trick I really haven't emphasized, but I think it's worthwhile to second. If we go to like 75, calculator fit. Yeah, that works. Make this a little smaller. We all want a beautiful mug, but move it and make it smaller. It's a joke. Okay. Right. So, yeah, one little trick that is worth it. I think just, well, I mean, you're not going to use it too often, but it's worthwhile to remember. When you simply have an interest rate change, but everything is the same otherwise, when you're using a time value of money keys, you can just input that new interest rate and you're okay. All right. Same thing with the number of years and the number of payments. If you're just going to change those, you're okay. I forget if you're okay with just changing the present value. Probably. Don't quote me on that. So I was going to make this a little quick. So of course, what I'm going to do is factor out a K here, and just add everything. So I could do that. Back up K. So, okay, I have this mess here. That's big, but that's okay. Smaller. Okay, so, and definitely storing the storage keys is your friend. 0.02 now. All right, so let's just get to it. 10N to interest 1 payment, compute present value, store it in one spot. I'm going to just change my interest rate, compute the present value, times 1.02 to the minus 10. Store that in the 2 spots. Just change the interest rate times 1.025 minus 10 times 1.02 to the minus 10 store that in the 3 spot. No, we don't need to do that, but really just take this plus 2 plus 1, and we get 21, basically 2160. Better than that. Okay. All right, so 100,000 equals 21.63K. So the usual, do 1 over and times 100,000. What happened there? But I probably should have saved. I have it here. Should have saved this. When in doubt, just save it in case you screw up like I just did. Yeah, I'm not sure what happened, but maybe I had 4,623,40. So you might get something slightly off, but slightly different than this, couple pennies. Probably at most 10, 20 cents. If you saved, if you actually saved everything. Okay, so right, so we need the outstanding balance after 8 years and after 25 years. So 8 is certainly right here. I guess we have 9 here. So I certainly have constant payments, constant interest rate of 2% between 0 and 8. So easiest thing to do is well, the only thing you can do really is your retrospective method, because going forward you do not have constant payments, constant interest rate. When I say, sorry, I should be clear. The only thing you can't use the simplified prospective formula. You can only use the simplified retrospective formula. You could still do the prospective method. It's maybe a good exercise. It's a giant pain to do, but it'd be a good exercise to check your answer. It's just not gonna, there's no super easy formula. There's not that super easy formula that we can use, because we need constant payments and constant interest rate going forward if we want to use the that simplified prospective method formula. All right, so retrospective method is as follows. The simplified formula. It's and I always like to remember what it means, because that helps me remember it. It's, the loan amount is growing at 2% for 8 years. So how much you owe is what the loan value is after 8 years minus the value of all your payments, time valued after 8 years. And this is 4,623,43 S8 0.02. So it's one spot. The other ones I could just add it up. That's okay. Right. Well, S8.02. So this is my payment. 8 and 2 interest, compute future value plus 100,000 times 1.08, 77,483. And again, you might get an answer off by probably $1 or so. Been doing a little bit of rounding. Okay, and now we do 25. That would be here. So again, in theory, we could do the retrospective method, but giant pain, because can't use the simplified retrospective formula, simplified method. But we do have constant payments, constant interest rate from 25 to 30, so you can do the simplified formula. And again, it's actually probably, if you're taking exam FM soonish, it's a good idea, I think, to do both and to check your answer. Giant pain to do the other one, but not a bad try. This is 8. Here. So yeah, the prospective method, 5, then my payment, 46233A, number of periods, number of years total minus my T, and we're using the interest rate here that we're given between 20 and 30. Interest rate after 25, which is 30. And yeah, remember what this is saying. This is just the present value of my 5 payments. So this is kind of just saying how much you owe is the present value of your last 5 payments. Makes sense. So what is this? 4623 here. Payment 25, 5 and 3 interest. Compute present value 21,173.90. Yeah, and I haven't really pushed this. I used to push this in the past, but one way to think about the prospective method is kind of through like a loan reset. So like you owe after 25 years, you owe 21,173.96, and if you want to repay that with a loan of certain payments, well, these would be your payments because if you take out a 21,173.96 loan, then the present value, the loan amount, is the present value of your loan payments. So it's very practical, makes sense. That if you want to refinance, basically, take out a new loan, pay this off, this is how much you owe. These would have to be your payments. So just another way of thinking of the prospective method. It's basically, the prospective method is basically like a loan lease. It's like a loan refinancing. All right, hopefully that made sense. So long, take care. Bye-bye.